Hello everyone, and thank you for joining us. Today we are going to talk about and show you modern DevOps for the mainframe driven entirely by open source software. My name is Tatiana Balaburkina and I'm the engineering manager for the open source supported tools group at Rocket Software. And my colleague Vladimir Kudryakov, senior software engineer in the open source supported tools group, will help me today. DevOps as a term took off about 10 years ago, but on the mainframe, as an important implementation initiative, DevOps has really taken off more recently. We will discuss and show you how modern open source based DevOps tools can coexist within the conservatively managed and highly secure platform that is the mainframe. As you can see from the agenda, we will walk you through three topics. In the first section, we will briefly cover the reasons for implementing DevOps principles on mainframes and that run on mainframe can mean more than one thing. In the next section, we will demo an actual DevOps pipeline built only with open source solutions driven from the mainframe. We will close the presentation with a description of elements and processes for maintaining security and compliance for the mainframe components of your open source based DevOps implementation. So why DevOps on the mainframe? Digital transformation has become an imperative. Organizations that deliver seamless and personalized experiences to their customers, unbounded by legacy technology and operating with greater agility, will be best placed to grow market share. The new priorities were underlined by the global impact of COVID-19 with massive and rapid shifts in demand. At the same time, the adverse economic headwinds of COVID-19 are challenging business margins. Traditional profit pools are under threat, pushing companies to rethink their business and operating models in order to reduce costs and achieve profitable growth. Next-generation technology and agility across the enterprise are core requirements to meet the challenges of digital transformation. And they are also key to hiring and retaining today's innovative talent. What does DevOps mean for us? It's not just about tools and architecture. DevOps is a culture in which people are continuously improving the product delivery cycle. Short dev-to-prod cycles, monitoring, control of each stage of the cycle, improvements, quality testing, and of course automation are key components of DevOps. Adoption of DevOps on the mainframe is an important enabler for digital transformation. So how to do it? Our customers come to us saying, my organization has mainframes and I am involved in an initiative to transform the way our mainframe applications are built, but I don't know where to begin. Regardless of the platform, the first step is identifying siloed processes. The aim of the new modern pipeline will be to consolidate them into a unified stream where each step will be automated, reliable, and observable. The following step is to choose the tools for automation. And this leads us to the point that the common DevOps toolset is open source and platform neutral. So abstractions layers can be used for easy integration of components that must run on the mainframe. Once you have implemented mainframe integration in your modern DevOps pipeline, it will enable a synchronized cadence across platforms for continuous delivery and continuous integration. A common point of confusion when it comes to open source on the mainframe is the fact that the mainframe is not just one platform, and open source commonly exists on free mainframe platforms. Two common options for running open source on the mainframe are Linux on Z and zCX. These solutions do make it possible to run open source packages and applications on the mainframe. However, as indicated by the lightning bolt icons, Linux on Z and zCX are essentially two forms of virtual machine, and as such, they communicate with the OS via network protocols. Only the third option, Unix System Services, which is a part of the OS, offers open source ports with direct access to traditional mainframe data and, in particular for the DevOps use case, direct access to source code datasets. So to consolidate why DevOps on the mainframe, it is of course to derive the benefits. Accelerate dev, test, and prototyping. Access to the latest, most productive and powerful tooling. And the enablement of next generation developers by virtue of providing them the tools they are familiar with. The outcomes of modern DevOps on the mainframe are lower costs and faster response to your market demands. How DevOps on the mainframe? Now we would like to demonstrate an example of modern pipeline built upon open source solutions. I would like to highlight that different organizations may use different tools and languages to implement the different roles and stages of a DevOps pipeline. This diagram represents what we use at Rocket to build some of our mainframe products, and it is one example of many possible choices. Also, I will add here, and in response to our customers that ask us where they should start, that the example pipeline we are showing you here today will be made available for anyone to download and study on Rocket's community forum. Let's start with the roles in DevOps. In the context of the demo, we will review two very important roles. First one, software developer. The software developer is the product builder. They are the ones responsible for writing new code and bug fixes. In our demo, development process is taking place on the OS, and such tools as Bash, Vim, Git are used. Working directly on USS, developers have direct access to mainframe files and datasets. At the same time, there are alternatives like Zoe VS Code Explorer, which enables to create and modify USS files, datasets, and jobs remotely. One of the key tools in DevOps toolset is a version control system. Git is one of the best and the most popular version control tool. It is a very powerful and easy to learn instrument that helps to manage source code changes. Git client is available on USS. Another role in the development pipeline is release manager. The release manager is responsible for the entire release lifecycle, automating and managing continuous delivery environments. Continuous integration, continuous delivery is a method to frequently deliver applications by introducing automation into the stages of application development. There are CI/CD orchestration tools that put together different parts of development process. CI/CD orchestrator is usually running outside of the OS. However, subroutines are typically performing on USS. The tool set that is used on this stage is determined by release manager. Build process in our demo requires such instruments as Git client, make, and curl to interact with Jira. And now I yield the floor to my colleague Vladimir, who will demonstrate how the pipeline works.
In this section, we will show how ZOS open source tools can be used to build and test a legacy project on ZOS. Unfortunately, we can't show the source code of a real product, so let's create a simple project that uses legacy programming languages. Here we have several source code modules in a dataset. For the sake of simplicity, they all are just hello world programs. Here we can see a C program, a COBOL program, and a PL1 program. This is the project we are going to use. It can be built using a build.jcl. When modernizing the development procedures for such a legacy project, first thing to do is to place all the source code into a Git repository. To do that, we need to copy dataset members into the USS file system. As a result, we have a directory with 3 source files. From now on, the source files can be edited not only in ISPF, but also directly in USS using the Vim editor. Let's create a new repository in Git for our project. An important thing to note is that files in USS can be stored in different encodings, either in EBCDIC or in ASCII. We need to tell Git what encoding is used for source files. This can be done by adding a file named Git attributes. Here we specify the encoding using the ZOS specific attribute ZOS working tree encoding. When a file with the attribute ZOS working tree encoding is added to the repository, Git converts the contents of that file from the specified encoding to UTF-8. Finally, Git stores the UTF-8 encoded content in its internal data structure called the index. On checkout, the content is converted back to the specified encoding. If a file doesn't have the ZOS working tree encoding attribute, its encoding is never altered when file is copied between the working tree encoding and the index. Some files used by Git itself, like .git attributes and .git ignore, must be always encoding as ASCII. Now let's use Git commands to add files into the repository. Next step will be to modernize the build process. We are going to replace the build.jcl with the tool named make. This tool allows to build the project piece by piece, depending on what source files have been modified since the last build. To use make, you must write a file called the makefile that contains instructions on how to build individual files in the project. We are using native USS compilers for programming languages C, COBOL, and PL1. And we use C89 command as a link editor. Let's run make to build the project. We can see the project has been built successfully. Nowadays, testing is an important part of the development pipeline. Let's create a bash script to test the compiled programs. It runs each program and compares the output of the program with an expected string. Run that test. We can see all the tests have been passed successfully. Let's add the new files makefile and test.sh to the repository. Now, since we are able to build our programs without errors and tests are passed successfully, let's push our local repository to a public hosting service like GitHub. GitHub provides useful collaboration features like commit history, code review, pull requests, graphical diff, and so on. To automate our development pipeline, we can use Jenkins Automation Server. Jenkins runs on x86. In our case, it's a Linux machine. We need to create a Jenkins job that connects to USS on the mainframe via the SSH protocol and runs commands to prepare a project for building, to build it, test, and post results to Jira Project Management System. To attach file and to post a comment in Jira system, we use tool curl that allows to interact with Jira via its REST API. Let's run the job. Our Jenkins job has two input parameters: task ID in Jira system and comment we want to post in that task. We can see that Jenkins job has been finished successfully. When we switch to the specified task in Jira and update it, we see our comment here and attached file with test log. Basically, that is all. Of course, this is not the only possible way to use open source tools with legacy projects. The pipeline we have just demonstrated can be modified as necessary. For example, we can place compiler output directly to MVS datasets if needed. Some legacy languages cannot be compiled in USS. This can be handled by creating a reg script or a JCL to build the source code on MVS. The script or JCL then can be run from the make file. As an example, we created a reg script to compile COBOL program in MVS. and JCL to compile PL1 program as batch job. Both scripts are run from updated makefile. Additionally, C program is compiled in USS, but linker output is placed to MVS dataset. When we run such makefile, all executable modules will be created in MVS dataset. The OS open source tools that we use during this demonstration can be installed with Rocket Open UpDev for Z, which use another open source tool, Conda, to install and update software packages. We will demonstrate how to install package, for example curl, and how to update it using Conda Package Manager. Installing curl package with specific version. All necessary dependencies will be installed automatically. Now update curl package to the latest available version from Conda repository. Ready?
Let's now move on to open source tools that are available for USS. Rocket Software is the leading supplier in the market of open source tools for mainframes. At the moment, our portfolio includes more than 20 components and tools that are valuable in the development process and CI/CD operations. There are languages like Python, Perl, PHP, as well as tools for working with source code like Editor Vim and version control system Git, compressors and archivers, zip2, gzip, zip, unzip, security tools, sudo, OpenSSL, and many others. We are constantly looking to extend and mature our portfolio of ports, and we are interested in your feedback, which other tools you would like to see included. And for customers that purchase the service and support product Rocket OpenUpDev for Z, this can all be downloaded and installed as a single bundle, and when new tools are added to the bundle, customers will get full support at no additional charge during the life of their contract. Let me tell you about strong sides of Rocket porting team. We have over 10 years of experience in porting open source tools to the OS. Although source code compilation with a native compiler is an important part of porting, the entire porting process isn't confined to it. In order to be operating on the OS, many tools require some mainframe-specific source code modifications. Our immense experience allows us to identify and implement the changes quickly and correctly. It is also about automation at every level. In our team, we are committed to DevOps principles. Our build and testing processes are fully automated, and security monitoring is a part of our infrastructure. It helps us to detect new CVEs and deliver the fixes with minimum delay. Finally, some of our ports like Bash are ported with GCC-based solution, which allows us to make builds with zero source code changes. For security and ease of use, Rocket has implemented a Conda-based delivery, deployment, and maintenance system for downloading, installing, and managing open source on ZOS. Conda is a prerequisite for obtaining all the tools included in Rocket Open App Dev for Z. Conda provides users an easy yet powerful installation experience. Conda solves the problem of dependency handling. First and second level dependencies will be downloaded and installed automatically. For example, though Git has several dependencies, with a single Conda command you can download and install Git and all of its dependencies. Conda also handles compatibility issues and will prevent users installing conflicting versions of tools. Environment management is another feature. It optimizes managing multiple deployments with different software versions within one system. The workflow for setting up and using open source tools on your system is shown on the slide. Miniconda is a prerequisite for all Rocket open source ported tools. There is one time step of one command to install Miniconda. After that, you need to understand whether you are using an air-gapped system or not. A primary reason why Conda was chosen for our open source delivery system was its channel feature, which is ideal for the mainframe use case. A channel is a software repository, and Conda supports three kinds of channels from which you can obtain open source software, keep it up to date over time, and manage multiple environments with different version requirements. Public Internet channels are repositories hosted by publicly accessible servers. Rocket has set up one such public channel with our full portfolio of ports for anyone to download from. Private secure channels are similar to public channels, though with restricted access. Rocket has set up its own secure channel server on our own network. This is the best and security solution for systems with restricted outdoor access. There is another solution for air-gapped system which is called local file channel. File channels are on-premise repositories for systems closed off from the internet. If you have an air-gapped system, the administrator will need to download solution bundles and periodically update them. However, each bundle includes the latest security fixes, version updates, and completely suitable for isolated systems. The exact same commands apply to all three types of channels, so users can retain the ease of use benefits of Conda while offering multiple levels of security. We would like to invite you to join us on Rocket Forum, where our customers share their success stories and where our ZOS experts help with product development. Our team also engages with our community of users by posting announcements and answering questions on the forum. Thank you for listening, and now we will be happy to answer any questions you might have.